Hello everybody, I hope you all are doing well. Welcome to another video reviewing your probability and statistics fundamentals. It's so great to be with you on a Monday evening. So today in this video, we're going to be continuing our discussion of the sampling distribution concept. So in the previous video, we've talked about sampling distribution for means, right? And we went through some example problems of, using the sampling distribution to estimate probabilities. Well, today in this video, we're going to continue that talk, but we're going to focus on sample proportions, right? And what do I mean by a sample proportion? Well, I mean that we're talking about, say, a percentage, right? So say we're sampling voters, right? And we see that, I don't know, like 40 out of the 100 voters have voted in the recent election, right? So we'd say that 40% out of 100 is our sample proportion in that mini example, right? So we're going to be studying this concept of sampling distribution for proportions, right? And a lot of the procedures to solve these problems are very similar to that of the previous video, except we need to keep a few things in mind. So say we have a sample, right? And we get a proportion. We're going to call it p hat, right? That's what p hat is. So p hat equals sample proportion. And basically, as you may have guessed, our sample proportion is going to be a good proxy to our mean of the sampling distribution proportion. So as you recall, if we have a bunch of sample proportions, right? If you have a bunch of p hats, right? We might have a distribution. So maybe you get a sample proportion as this red dot, maybe this red dot, this red dot, this red dot, this red dot. And I'm going to populate this distribution. And as we do this, right, we're going to build this distribution of sampling proportions, right? So we're going to be applying a similar concept, but study sample proportions and how they're distributed. So p hat is our sample proportion. This is the mean of our sampling distribution proportions, and this is our standard deviation of the sampling proportion, right? So basically, as you can see here, to find the standard deviation of a sampling distribution of proportions, we actually use our p hat in our computation. So this p right here will represent this p hat. Now, these two inequalities will represent our normality check, right? So as you recall in sampling distribution of means, we checked if the sample size was at least 30 or if we were sampling from a normal distribution to check for approximately normal. Well, in this case, here's the heuristic that we use to check for normality for sampling distribution proportions. Now, you may see this inequality in this form, but this 10 might become like, say, a 15 in some sites you'll see. Don't worry too much about that. The concept still remains the same. It's just that certain books and websites have defined this normality condition a bit differently, so they might change this 10 to say a 15, or they might change it to a 5. It really depends on what resource you're using, but let's not worry about that for this video. We're going to use the normality check here as is to do the problems that we need to do, and it'll still get the point across though. So let's dive into the example. So example 1, we have a sample of 500 students, right? So n equals 500, that's our sample size. And we know that 230 of them like M&Ms. So 230 out of 500 like M&Ms. And we want to find the probability of getting a sample where at least half like M&Ms. So what do we need to know? Well, we need to know what our sample proportion is. We need to know what our p hat is. Well, we see here in our sample 230 out of the 500 students like M&Ms. So p hat is going to be 230 over 500. And this is going to be 0.46. Now, before we do anything, we have to check for normality. That's our next step. So we need to test that 500 times 230 over 500. That's going to be p hat. This will equal 230, which is greater than or equal to 10. We will also check for n times 1 minus p hat. So that'll be 500 times 1 minus 230 over 500. That's going to equal 500 times 270 over 500, which equals 270, which is bigger than or equal to 10, right? So we see here that the normality checks pass, so we can say this sampling distribution is approximately normal. Now, since we're having an approximately normal case, we will use which statistic? Well, we're going to use the z statistic, right? Because the z statistic represents the normal distribution. So we're going to have to calculate our z-score. Now, to calculate the z-score, we simply take our number, right? We call it x minus the mean over the standard deviation. In the case of a sampling distribution of proportions, we know our mean. It's simply the sample proportion right here, right? So it'll become x minus p hat over standard deviation. And we literally have the formula for the standard deviation of this sampling distribution. We're going to put this term right here, or underlined in red, in our denominator. So it's just going to be this. This is going to be our denominator, or our standard deviation. So you can see here how I'm putting the pieces together, right? So you don't have to necessarily memorize how to get the z-score. As long as you know where your mean and standard deviation are, you can essentially plug in and chug like what you need, basically. So in our case, for the z-score, right? So we want to find the chance of getting a proportion, right? Or we want to find the chance of getting a proportion p hat that is at least half, right? So we want this probability, right? Well, this is simply equal to the probability of getting a z-score at least 0.5 minus 0.46. I'm just basically plugging in the terms. So we have p hat as 0.46. The proportion we desire is 0.5. Our standard deviation is going to be the square root of 0.46 times 1 minus 0.54 over 500. So that will get you your standard deviation. So I'm going to punch this into my calculator real quick. So give me a moment to get the z-score. And you can even follow along too, like on your calculator. So this is going to be the probability of getting a z-score at least So the z-score we're after is getting a z-score above 1.79 approximately, rounding to the nearest hundredth, right? Okay, so we want the probability of getting a z-score at least 1.79, right? But if you remember from our z-table, right? Our z-table will take some z-score, right? And give you this probability right here. So the probability of getting a z-score less than or equal to this point here. But in our case, if our z-score is 1.79, right, we want this area in green. We do not want this red area, which is what our table will give us. So we have to subtract out the red area, right? So this is going to be equal to 1 minus the probability of getting a z-score under 1.79. So if we look at our z-table, we need to look for 1.79 in our table. So if we go down to 1.7, we go to 1.79, we see that the probability of getting a z-score less than or equal to 1.79 is 0.9633. So this is going to be approximately 1 minus 0.9633, which is approximately 0.0367. So this is the probability of getting a sample of 500 students where at least half like M&Ms. So this is the probability. It should be relatively straightforward. So we'll move on to the second example. Now, in the second example, we have a sample of 15 tires, right? And we see that 8 out of the 15 have a low PSI. We want to find the probability of obtaining a sample of 15 tires where less than 55% of the tires have a low PSI. So let's break this down. We know that N is 15. This is the number of tires. We know our sample proportion, P hat, is 8 out of 15, right? Because we said that 8 out of 15 tires have a low PSI. We want to find the probability of getting a sample where the proportion is less than 0.55, right? So we want to find this probability here, right? But before we proceed, we need to do our normality checks, right? So we have 15 times 8 over 15, right? It equals 8, which is not greater than or equal to 10, right? So this fails. And we'll also see that 15 times 7 over 15, that's 1 minus p hat, is equal to 7, which is not greater than or equal to 10. So both these checks fail. So what do we do if we can't assume normality? Well, we're going to use the t-distribution, right? Because with the t-distribution, we can get a t-score and still use our t-table to get the probability we are after, basically. So we want the probability of getting a sample proportion that is less than 0.55. Well, we're going to convert this in terms of t-scores, right? So we're going to take the probability of getting a t-score that is less than the following. So 0.55 is the desired proportion. We're going to subtract it from p hat, which is 8 over 15. Notice how when we compute the t-score, we're doing the same procedure as above to compute the z-score, right? Except we're using the t distribution instead of the z distribution. So now that takes care of the numerator. Now to get the denominator, we need to use the formula for the standard deviation of sampling distribution proportion. So it'll be 8/15 times 7/15 over 15. So that will give us the following probability where the t-score is less than. Let me punch this into my calculator real quick. So that will be getting a t-score of less than 0.13 approximately, right? So and because we have a t distribution, right? We know the degrees of freedom is 15 minus 1, which is 14, right? So our goal is to go into our t-table, we look for where the degrees of freedom is 14, and we keep going right until we find where the t-score exceeds 0.13. Well, when we see in degrees of freedom of 14, the first t-score that pops up is 0.692. So 0.13 t-score is much less than 0.692. So our probability is our probability of getting, t above 0.13 is, larger than 0.25. Now, and if you look carefully at this table, right, when we take a t-score, right, the probability that you're going to see up here is going to be this area right here. We don't want this area. We want the area to the left, basically. So our area to the right will be a number larger than 0.25. So 1 minus the probability of t greater than 0.13. So we're subtracting out that rightmost area, right? It's going to be, some number less than 0.75. Now, I can't compute it exactly with this table because I don't really have, any more probabilities here to see which t-score matches up. So I can give you like a rough approximation, but what I would recommend is, use a t-statistic calculator, right, to actually get the probability in a little bit more exact form. But the general idea or the general procedure should be somewhat pretty standard though. So that takes care of sampling distribution proportions. This walkthrough shouldn't be terribly difficult if you watched a video on sampling distribution of means. We're just using a different distribution, but the procedure for solving these problems remains the same. So hopefully you've enjoyed this video, and I look forward to seeing you in the next one. Till then, have a good rest of your evening.